All right. Well, good morning, everyone. Good morning. Thank you for joining us for this event of celebrating our associate professors. It's one of the most exciting times in the year when we get to do this. We're celebrating three colleagues today, MSc, ME, and ECE, all three departments represented here today. All right, so I just want to remind everyone of why we do what we do, why are we doing this, and there are three key points. The first is we're here to celebrate the success. It's extremely hard to get into a place like Purdue as a faculty member. And if you think that's hard, trying to go through the first 6 years and doing everything that's needed to succeed to get to be promoted is, most will tell you, it's the hardest thing they've ever done. So it's really an opportunity to celebrate the success because it's a very difficult path, and the colleagues we're celebrating here have been exceptional in their ability to get here. So we're here to celebrate. We're here to share. Each one of these colleagues that we are celebrating today has their own path to how they did it. Key decision points in their career where they made a decision that really helped them succeed. And this is not about the technical content of, the papers they've written. It's about key turning points in their career that enabled them to succeed the way they have today. And that's really for sharing with other colleagues in the audience who are assistant professors who will be coming up in the coming years. It's a great idea for them to hear this, for our postdocs and grad students in there. So you hear about these, the intangibles that allow for success if you choose this path, right? So this is a great opportunity to share that. And thirdly, it's about collaboration. There are colleagues from more than the three disciplines here that we just spoke about, many more, actually. And so this is really an opportunity for you to learn about, talent that's being celebrated from other disciplines and see where there are areas for collaboration. So how can we make this a starting point for something new so that when the next promotion happens, there's an entire different set of disciplines sitting here to celebrate the success of the colleagues we're celebrating today. So with that said, thank you all for being here, and let me hand it off to who's opening. Who's Mellon? Mellon, over to you.
Hey, everybody. For those of you who don't know me, my name is Milan Kulkarni. I'm the Michael and Catherine Burke Head of the Elmore Family School of Electrical and Computer Engineering. It's a very long title, but I'm contractually obligated to use it every time. It gives me incredible pleasure to introduce the first presenter today, Chris Brenton. So Chris has been a colleague and friend of mine since he joined us here at Purdue in 2019. So he got his PhD from Princeton in 2016. He'll tell you a little bit more about his journey, I'm sure, in this presentation. So I won't belabor that part. He's been here since 2019. He was named an Elmore Assistant Professor in 2023 and was promoted to Associate Professor this year. In high school, we talk about people being multi-sport stars, right? They star at baseball and football and track. I like to think of Chris as one of our multi-sport stars in ECE. When people are going up for promotion, they go up on three dimensions, right? They go up on research and teaching and service. And Chris has excelled since he got here at all three. And you'll hear about some of these things now, but I do want to brag a little bit because I don't know if he will brag enough. So on the research side, Chris has been one of the pioneers in edge computing and in applying machine learning to networks. And that research has been recognized by 4 different Young Investigator Awards from the NSF, ONR, AFOSR, and DARPA. In fact, he was just named, just got the DARPA Directors Fellowship this year in recognition of that DARPA work. So that's just a taste of the excellence that Chris has delivered on the research side. And that's something we're used to seeing from a lot of our associate professors. But he's also excelled in teaching. Since he got here, I had the pleasure of actually teaching with him in his very first class at Purdue. We co-taught what is now the required data science course for all Purdue ECE students, and he was one of the developers of that course. And his excellence in teaching has been recognized by multiple departmental awards, as well as by the college's early career teaching award. And so he's excelled on that sport as well. And then finally, in service, Chris is one of those faculty members where I actually have to restrain myself because every time I ask him to do something, he says yes. And so I don't want to overburden him because he really hits it out of the park on basically everything we've asked him to do over just the 5 years that he's been here. He's already established himself as one of the irreplaceable faculty members in ECE. So without further ado, I would like to welcome Chris to talk about his path and his journey.
Thank you so much. Thank you, Arvind. Thank you, Milind. Arvind said this isn't supposed to be about our papers, so I guess that throws away my plan. I was going to just walk you through one of my proofs and one of my recent papers, but I guess I won't do that in here. I'll save you the boredom. And Milind, really appreciate all the kind words there. And I hope you appreciate the what's the word in my title, the pun that I have, my path, present and future, instead of past, present, and future. Oh, I don't need this. Oh, okay. Sorry. All right. Cool. Okay. All right. So yeah, I want to tell you a bit about just me. And so this isn't so much of a boring research talk. It's not supposed to be. So I was born and raised in the great state of New Jersey, also known as the armpit of America. And I'm very proud of that, actually. So some things that, maybe some of you know me, some of you don't. I actually, before I was like 13, 14, I wasn't particularly like great student. I mean, I wasn't necessarily like a bad student, but, I think a lot of people look at professors as being, people who were just amazing students from day one. And that definitely wasn't me. I think the time that I really started to click academically and really sort of become more passionate about it was around the time too that I discovered what is still my main hobby today, which is musician and playing guitar. I try to always keep that going, but around 14 I did become very interested in playing guitar, all different types, acoustic, electrical, classical, you name it. If it has 6 strings, I'm interested in it. Even 4 is okay for bass sometimes. But I think that these two things were somewhat synonymous because a lot of times I look at music as being able to recognize patterns, patterns on instrument, patterns on a fretboard, and to me that's a lot of what at least math comes down to be. And so I don't know. I think I can't prove this with a theorem and a proof, but I think that these two things are very related in a sense. So at that time too, I did become very interested in math. This is a picture of me. I think when I was 17, I probably just gotten my driver's license with my band in high school. We were playing out at a gig somewhere. I remember it was a Sunday because I remember I had to get back home and finish my calculus homework for the school the next day. So that's true. That's the truth. That's not just made up. So in college, I did my undergrad at a small school in New Jersey called the College of New Jersey, where I met my wife. She's not here, so I can say the only thing I'm particularly proud of about my undergraduate is that is where I met my wife. It's a fine school and everything, but not too many exciting things going on there, except for one thing I would like to point to. This man, Alan Katz, he actually passed away about 3 or 4 months ago, but he was an incredible mentor to me. It really got me interested in the idea of doing research. So I wrote my first couple of papers under his guidance. He's in the RF or microwave field, and he actually spent his whole career building what are called linearizers, particularly for space systems, and then later for photonic systems, where he would actually try to correct for nonlinearities in systems to make them linear by literally creating through analog circuitry the exact opposite of the frequency and power response. And so he was very successful, and his company sold, I think a year before he eventually passed away. So rest in peace to Dr. Katz. So then I went and did my PhD at Princeton, starting in 2011. I was always interested in optimization, networking, and data science just from the time that I started. You might recognize this guy on the left here. I won't say his name, but this is what I remember him looking like back at the time that I did meet him. Those palm trees in the back, I think, are Stanford back there. very serious, always, a little bit different than he is today. And on the right there, that is Vince Poor, who has always been a really incredible mentor to me and was served on my PhD thesis committee. And so when I was a graduate student, I did research, of course. I mean, we all have to, but I also got an opportunity to do a lot of teaching there as well. So I was very involved in massive open online courses. This was the time when MOOCs really were becoming a big deal. So on Coursera, I had the opportunity to co-teach 2 classes, one of which ended up spinning off into a book that I wrote called The Power of Networks. And full circle, we actually last year used that book to teach an undergraduate interdisciplinary course through the Honors College to students, from both in and outside of STEM disciplines. So it's really meant for that kind of a background. And then the thesis that I wrote was on machine learning in social learning networks, actually, which is a little bit different than what I work on now. So I kind of shifted a bit in terms of my focus, but I find a lot of the background material is still very, very applicable. So after school, before Purdue, I co-founded a company called Zoomy Inc. That still exists today. It's a machine learning and analytics company for corporate training. So I had an opportunity to lead a team there of data scientists and data engineers, varying different sizes depending upon how many customers we had or didn't have at any particular point in time. But it was a great experience, very busy. Millen said, I have a hard time saying no to things. So at the same time, I also got an opportunity to return to Princeton as a lecturer. So I actually had 2 full-time jobs for about 2 years at Zoomy and at Princeton. That was a full-time gig too. I was a lecturer and also became an associate research scholar. At that point in time, that's when I really started to pivot my research focus towards what it is now, which is edge computing and communications. So what do I do now? Well, I do edge computing and communications. So this is now the boring part of my talk. So what is fog networking, right? So today, we have billions of connected devices, right? And they're exponentially increasing data generation at the edge from everything that we do, from the Internet of Things, from our own data-driven services. Of course, that's fueling advances in AI and ML. I mean, the billions of devices and the exponentially increasing sizes of data that we have just motivates us to do research on data. And what people don't normally think of, though, at least in the machine learning side, is how do you actually do this training and management of large models over practical network systems? And so that's what I try to do. I look at more of the infrastructure and orchestration side of machine learning. So I look at advanced edge intelligence, which is a principal objective, 5G, 6G, next-G access. I look at services that are both data intensive and latency sensitive. Those are 2 very contradictory objectives, but we have to try to do the best we can in terms of trading them off. And I look at doing this over not just edge networks, but over fog networks. And so fog networks refers to the continuum of resources we have from cloud services or cloud data centers up to the Internet of Things on the edge. And the whole complex hierarchy of elements that are in between, which have very heterogeneous properties, very heterogeneous computing properties. Consider the difference between your smartphone, which today may be very powerful, and perhaps an older generation phone, or a sensor that can only handle a few operations in a second, something like that. And so federated learning is a very popular technique that was pioneered by Google to do distributed machine learning over a set of edge devices. Federated learning follows what we call a star topology, where we have a server in the middle and we have a whole bunch of edge devices that are connected downstream from that. Federated learning is great in certain instances, but in a lot of cases, it actually fails us from scalability perspective, because a star topology does not represent what we normally see in networks. They're normally much more hierarchical and complex and heterogeneous. And so a lot of my research builds upon 3 key challenges and opportunities from the pitfalls of federated learning. Heterogeneity in local resources and data set statistics. So every device may have different set of data drawing from a different statistical distribution. The unique topologies, the proximities, of course, between wireless devices. And so I use fog learning as a term to talk about two things. One is how fog computing benefits AI and machine learning by providing distributed orchestration to jointly optimize intelligence quality and resource efficiency. And then on the other hand, how AI and ML can improve fog computing and edge computing. So how we can learn to optimize and defend networks better using advances in state-of-the-art AI and ML. So my research is a combination of theoretical developments. My students, I shouldn't say my students who are here, thank you all for coming, do a lot of theoretical analysis, very cool mathematical proofs to try to come up with relationships between how fog computing is configured, what model training performance looks like, and what the network resource utilization looks like under different heterogeneity properties. And we in turn use that theory to try to develop adaptive orchestration methodologies for changing how networks operate and adapting their operation according to different device level, fog level, and cloud level decisions we can make. So everything from how many data points should my smartphone process in a given instance of time, up to what should the frequency be of aggregations at a global server, right? And everything in between. Should I share information with my neighbor to improve the learning quality? What happens in that? Is there some privacy security implications? So there's a lot of objectives that we sort of build upon there. So I lead what's called the ION Lab, as I like to think of my students as positively charged particles. So ION stands for Intelligence and Optimization in Networks. I actually was naming this around the time that ICON got its name, and maybe I saw the name ICON somewhere, but it actually took me a really long time to come up with this name. So I don't know. Maybe I should sue them for plagiarism. No, I just want to be clear. I did not steal this from ICON. Okay. So composition: 1 principal investigator, principal idiot. That's me. 3 postdocs. We have 6 alums as well. 12 PhD students currently who are sitting in here. 5 PhD student alum who are some in academia, some gone to industry. 2 master's students, 3 alums, 2 undergraduates, 5 alums, some of whom actually are now PhD students. 2 of them, Adam and David is here somewhere too. Here, David. Yep. So some of the sort of boring metrics that I really can't take credit for because they're the ones that are doing it. 60 journals, journal equivalent conferences, about 60 other conferences, and considering money coming into Purdue, about 17 million or so there that we've gotten from these wonderful funding sources here. So I next would just like to thank from the bottom of my heart many wonderful mentors that I've had who are in this room right now and pictured here. So there's so many more that I'm not even naming, but David Love, Jim Krogmeyer, Mike Soltowski. Of course, I must name my PhD advisor, he who will not be named. Chi-Chun Wang, Mark Bell, Milland has been and continues to be a wonderful mentor to me, and Shreyas Sundaram as well. I can't forget the amazing administrative staff that we have helping us always to do, really just handle emails from us sometimes at all times of the day and deal with our crazy calendars and forgetting to go to meetings and, not showing up to things. And so, Kendra and Sigren, who's my business manager, and of course, all of my, students and postdocs, I thank you from the bottom of my heart. And I also thank my immediate family here. So on the left here, this is Adam. He's 3. He's currently in school. He's actually at Purdue. We got him working on calculus right now. He's doing pretty well. There's some things we're trying to brush up on, but this is Nate. Nate is 9 months old, and they actually get along really well. I hope that stays, but I don't think it will. And my wife Kate. That's us a couple months ago, I think. And then of course, our dog, Sammy, who's been through all of the moves that we've made, many different houses we've lived in now. So go ahead and end there. Thank you very much.
Anybody have any questions for Chris?
Should Adam be what? He's a little behind. I mean, I'm trying the best I can here, right? We got this Adam. He's in, the other.
Okay, let me try to break the ice here a little bit. I'm expecting folks to come up with their own questions, but I think a question that comes up here, Chris, is you showed a whole bunch of, sponsors,
Yeah.
congrats on I can't even count now the number of early career, grants you've got. I mean, each of those, especially the early career or the large grants, is a considerable corpus of work that
Yeah.
you're proposing. So when you try to go after many, does it mean you're basically giving up more time than you actually have to do, or are you leveraging one? Are there things that are common that you like? Because it's impossible if they're totally orthogonal.
Yeah.
5 early career awards. Like how do you do this? Like what's the strategy there that others might follow, so you don't just burn yourself out? Sorry.
Well, I might turn the question back to you because at the moment right now, I'm also trying to lead a ERC pre-proposal, and I do have an annual program review for one of these next week. So I don't know. I mean, I'm just trying to take it as it comes, and it is very hard actually not to burn out. I mean, I actually do feel burned out quite a lot. So I think part of it is you do have to start to say no to things, and maybe that's now I'm at the time of my career where I do need to start saying no. And but in general, a lot of these different awards, they're all distinct, right? I mean, I'm not trying to double dip or anything like that in terms of what I'm getting money for. They share some common principles in terms of this fog learning paradigm of looking at heterogeneous distributed AI and ML, but they look at very different network systems, right? So that's how they're sort of differentiated. So my career award looks at more of commercial networks, more commercial systems. My DARPA award is actually focused on satellite communications. My ONR one is focused more on defensive settings and ad hoc wireless sensor networks that may be deployed. My AFOSR one is more like aerial UAV networks. So they're all different types of network systems that share some common principles. So a lot of times when I have papers that I'm publishing, they may be relevant to potentially multiple of them, because if we're doing something that's more theoretically grounded, it's not necessarily dependent upon the particular network system, right? But then it does become very hard to then say, go to every annual review and make sure you're very well prepared for it. Huge balancing act. And I rely a lot on the, 15 or so folks who are in the room, who are in my group, to help me. Originally, it was mostly just with paper writing, but even now, especially postdoc level, just getting them opportunities, writing grants, I think that's really helpful. It's mutually beneficial, right? Because postdocs also want to become faculty members. So having them help you and in different ways as well too is good. So I guess I don't have a clear answer, right, for how to do the balancing, but the one thing I would say is just make sure you don't push yourself hard enough where you stop enjoying what you're doing, because it's easy to do in this career.
Can you say a few more words about your undergraduate times in terms of
Yeah.
summer work or undergraduate
Yeah.
research, stuff like that?
Absolutely. So when I was an undergrad, the first couple of years, I didn't focus too much on research. I went to it was more of a teaching oriented school. There weren't as many opportunities for research. So I think my first summer I interned at AT&T in Bedminster, New Jersey. So there I was actually doing spreadsheets, but it was a little cool part of spreadsheets because I was like building automated lookup processes and stuff. And so I was basically like trying to write C code in spreadsheets. It was kind of cool. and other than that, just sitting at my desk trying to figure out what to do, like a lot of interns are doing always. My sophomore year, I got more involved in research over the summer. So I actually participated in what's similar to an REU program. It wasn't called an REU, but it was at my undergrad, and then I also was working at my my undergraduate advisor, his company. I was working there and getting some experience. Then my junior year, actually, I was at AT&T Labs in Middletown, New Jersey, working in an optical communication networks lab. And that's really the first time that I got exposure to, say, like writing journal papers. And so I think my first journal paper actually came out of that kind of work. And then after my senior year of undergrad, I was trying to get ready for grad school and, to compete with the best in the world, that were coming in from all over the world. And so I was trying to get a head start on my PhD at that time. So yeah, so I think I gradually got more involved in research. Any other? Yeah. It changes seasonally, and it really does. You ask me right now. My favorite song is Panama by Van Halen. Definitely. That's the best song it's ever written. My favorite style of playing guitar.
That opinion?
We're gonna what?
Are we allowed to pull your tenure for that opinion?
Ooh. I mean, if you think you can replace me. Sorry. Wow. Sorry, but you threatened me, so is it possible to do that now, right? I mean, it's like 10 years, like not a yeah. Oh, okay. All right. Probably blues right now. Like Stevie Ray Vaughan. But I also play, metal and classic rock. I grew up doing a lot of classic rock stuff, so yeah.
Who are you named after?
Yeah. So anybody familiar with the band Yes? And yes, no, yes. I'm actually named after the bass player, Chris Squire. And my dad actually was just there seeing. I mean, Chris Squire passed away a long time ago, but 10 years ago, maybe 24. I think it was like 2014. But he was there seeing their lead singer on Sunday with my brother. So in New Jersey, the armpit of America. Yeah. All right. Well, thank you all so much.